guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our book of Introduction to Marine Engineering, and we are going to continue with the chapter 4. This is about the nomenclature of the hull, the nomenclature of the boat, and also we are going to calculate the hull speed. We are going to calculate the torque, the horsepower. This is a great episode. I hope you enjoy this episode. We are going to start with the description, the general description of the boat. Okay, we need to be familiarized. We are going to check the boat from the back. And our right hand always will be the starboard side. The starboard side, this starboard side over there. And our left hand will be the port side. Once again, we are checking the boat from the back. And yes, this is the forward or bow, and this is aft or stern. Exactly the same like this. We have a bow over there. We have a stern in the back, and this is the starboard side. This is the starboard side, and this is the port side. And the white of the boat is the beam. Yeah, this is the beam of the boat. This is the beam of the boat. Important measurement. The water line, you remember? The water line is this line. The water line. Port side, starboard side. Bow is the front of the boat. Stern is the back of the boat. Always, always. Okay, and we are going to check other dimension, the water line. Remember, the water line is the distance in between the transom and this point, and this is the total length of the boat. We are going to learn right now that the water line normally is 85% of the total length, approximated. We have a port side, a starboard side. Here we have that the keel. This is the center line of the boat. Here in the middle, that's the keel, right? And we are going to start to check internally what happened in the structure of the hull internally. And we are going to start with the bulkheads. Those elements that are perpendicular to the axis of the boat. Those are the bulkheads. Those are the bulkheads. The bulkheads are walls within the ship that separate different areas. One of the most important bulkhead in a boat is the engine room bulkhead. That the wall that separates the engine room with the cabin. That wall is a special wall. For insulation, for everything, because that's the separation in between the engine room, a lot of noise, a lot of temperature, and the cabin. Okay, this is one of the bulkheads. The majority of the bulkheads are not non-structural. They are non-structural. However, in some small boats, they are part of the structure. In big boats and mega yachts, it's considered that they are not structural. But at the end of the day, they are part of the structure. The bulkhead doesn't provide structural strength. Instead, the frames that support the bulkhead, called the bulkhead stiffeners, they added structure to the system, to the complete system. Those are the bulkheads. And now we are going to talk about one of the most important elements in the structure. Is the stringers. Those are the stringers. Stringers run from the front to the rear of the boat. One stringer is called the keel. That stringer is located in the bottom. Yeah, that's the keel. It runs from the bow to the boat into the transom of the boat. That's in the center of the boat. Those are the stringers, my friends. Those are the stringers. Those are the stringers. and the stringers are a very important part of the structure. Let me tell to you something about the stringers. In my opinion, the quality of the boat depends on the condition of the stringers and the condition of the transom. Yes, remember that over the stringers is located the engine. The engine release on the stringers. If the stringers, normally the stringers right now we are going to check internally, they are with a foam or wood. If that foam is full of humidity, full of moisture, the stringer is gone, and the balls that support the motor mounts on the stringers, those balls are free, and the motor mounts are free, and the engine is not aligned. And you have a lot of inconvenience, vibration, noise, and a lot of problems because the stringers are in bad condition. For that reason, my recommendation when you buy a boat is ask to a professional guy in order to verify if the stringers and the transoms are in good conditions. Because if the stringers are damaged and the transom is damaged also, the price of that boat is zero. Because normally the reparation of, yes, you can repair the stringers. In this project, you look at this, we remove all the stringers completely, and this is a project that we did in this class and in the class of composite materials with our students. And after that, we fabricate the new stringers for the project in foam, and we cover it with fiberglass, and at the end we paint the system, and that was the final result. Yes, and we did the same with the transom. Right now I am going to pass the slides about the transom, but this is a big job. You need this disassembly the boat completely. You need to remove engines. This is like a build the boat again. For that reason, the life of the boat depends on the condition of the stringers and the condition of the transom. Can I repair? Yes, but it's a lot of work. It's hard. No, I have a space in my home. All right, you need to be careful with the neighbor because you need to cut it a lot of fiberglass. That's not good for the environment. Okay, for that reason, be careful when you try to buy a boat. Be careful with the conditions of the stringers and the condition of the transom. Yes, this is the typical situation when the stringers are replaced. Those are the stringers, and yes, there are stringers with the wood inside, and after that covered with fiberglass. Or there are other type of stringers with the foam. This is the foam, and there are stringers that they have the foam or the wood covered with fiberglass, and after that reinforced with aluminum brackets. Those aluminum brackets like this are excellent because in those aluminum brackets you can bolt it the motor mounts in a proper way, and after that the engine is not disaligned. The engine is completely aligned all the time, and you avoid 100 of problems, proportion problems. Yes, in the next coming chapter we are going to talk about that situation. Those are the stringers. The stringers are critical. The stringers are structural. They are part of the structure of the boat. In a future episodes related with the diesel and gasoline engines, especially in the diesel course, I am going to explain the procedure to convert the boat, to repower the boat from gasoline into diesel. What is the meaning of that? We are going to remove the gasoline engines, and we are going to replace those gasoline engines for a diesel engine. The value of the boat increased dramatically. The price of the boat is other price. higher price, because the diesel engines have a great reputation, especially in the marine industry. In that conversion, one of the steps in the procedure to convert the boat from gasoline into diesel is reinforce the stringers. Yes, because the diesel engine produces too much torque, twice or 3 times the torque that a regular gas engine produces. For that reason, the stringers, the quality of the stringers, the thickness of the stringers should be better than the original stringers for a gasoline boat. And additionally, those stringers should be reinforced in aluminum in order to install properly the motor mounts. Yes, I am going to explain the process to do that procedure step by step. You found that process in my book of diesel, in my course of diesel. You enter in my webpage and you buy the course and you take the course, and at the end you have the certification related with that course. This is a wonderful course. This is one of my best sellers. Yes, the diesel class is a wonderful class. And yes, in that book, in that course, I'm going to explain the procedure to repower a boat, and especially the procedure to repair the stringers and reinforce the stringers. This is a vital part in that conversion, because remember, the diesel engines are strong engines in comparison with the gasoline engines. Yeah, the spinal dorsal of a boat are the stringers. The life of the boat depends on the condition of the stringers. Yeah, the majority of the boats that you found in internet for nothing, for free, is because the stringers or the transom is broken. For that reason, the boat is out. Once again, yes, it's possible repair, but in some cases is more expensive the reparation than buy a new boat. For that reason, be careful with the condition of the stringers before you buy a used boat. Okay, this is in relation with the stringers. With the transom is exactly the same. The port and starboard side of the boat, they are connected by the transom. The transom is located in the back of the boat, and there are different types of transoms, no? Transoms that are completely solid transoms, and transoms that are section transoms. For example, this type of transom can be closed completely to convert the boat in other type of boat. We have a great example in the marina of Mr. Rodriguez. Originally was a half transom, and the transom was closed and reinforced in order to install a bracket, a big bracket for an outboard external. This is the process. Danny, this is another great example of the reparation of the transom. Originally, it's an open transom.
Yeah, the transom was down here.
Correct.
And we closed it in to fill it up. This is still in the process.
Okay.
And also we're repainting the whole entire boat. This is a complete restoration we're doing on it.
With which material you fill the transom?
This is, well, it's going to be, you're going to use biaxial, and you're going to use marine plywood.
Correct.
Or you can use a core. And this guy didn't want to spend the money, so he went with the marine plywood.
This is the thickness, no?
And this is the thickness. It's pretty thick.
All right. And perfect. And you put some metal in between?
No, I put no metal in there. Because what happens is he's going to put a bracket, a swim platform bracket here.
This is the next step.
And that's the next step.
All right.
There's the old bracket, and you can actually see here.
Yeah, this is the video that we checked before. Okay, and the idea is that Kiki fabricate a new bracket in this way. Danny and Kiki, we are in front of the worst scenario. This is a bad combination, no?
Yeah, well, what they did is this is actually a fiberglass swim platform, which this was an add-on feature, but it's all fiberglass. And if you notice, look at the wood. Look what happens to the wood when you make it fiberglass. Fiberglass or wood. It rots.
Yeah.
And then what happens is, and Kiki will explain to you, and like you know how Kiki made that other platform that has closed in? They made wood. Look. And then the material inside never got fiberglass.
And it's polyester resin.
Right.
That's not good.
And you see what happens to the wood?
Yeah. Oh no, of course. Absorb humidity. Exactly. This foam is not good, no?
No, sir. That's the worst thing you can do.
Yeah.
You never put any foam and inside the bracket.
Yeah.
For a lot of reasons. Okay, number one, that absorbs water.
Of course, a lot.
A lot. And another thing is, if the Coast Guard, they close that, and they want to see what is inside there, okay?
Oh, yeah. Penalty?
And they poke a hole.
Penalty for that?
Oh, yeah.
Penalty.
They're looking for drugs.
They're looking for drugs. They're going to cut your bracket.
Oh.
Okay?
Additionally, there are closed transoms with the holes for steam drive systems. Yes, this is a good example. This is the transom with the holes for a steam drive. Okay, and yes, the life of the boat depends on the stringers and the transom. Can I replace the transom? Yes. For example, in this particular case, the transom. This transom was other project in our class of composite material. Yes, we cut the original boat. We remove all the parts, and we fabricate the transom outside, exactly with using the pattern of the original. We fabricate the other one, properly reinforced with plywood and foam in both sides, and after that we install the transom. We cover it with epoxy resin. After that, we cover with Bondo, and we paint with a special gel coat paint. And this is the final result about that project. That was a project for a group of my students in the class of composite materials. Yes, you can repair the transom once again. You can convert the transom like Mr. Rodriguez did in his shop, but it's expensive. In some cases, it's less expensive buy a new boat. But the life of the boat depends on the condition of the stringers and the condition of the transom, with question. Yes, the transom, especially if the transom support outboards, produce a lot of torque, especially in this area. In this area, this is the area that normally is cracked, and also on the sides is because the torque produces for a bracket like this with an outboard is a high torque. Yes, there are companies that reinforce the transom with aluminum brackets. Look at this worst scenario, Danny.
Wow.
The water is penetrating in the transom, and probably this transom is full of water.
Yeah, well, absolutely. With that open, not only that, they put a Band-Aid on it. They put this aluminum piece.
This is a cosmetic.
It's a cosmetic.
Because this bracket is supporting, but it's provisional.
Yes.
That transom,
That's a temporary fix.
Correct. That transom is broken internally.
Yeah.
But I recommend reinforce the transom with aluminum brackets if the transom is in good condition. Don't try to reinforce the transom with aluminum or stainless steel bracket in order to cover internal problems of the transom. I recommend repair the transom, try to do the transom new one, additionally reinforce it with metals, aluminum or steel. In some cases, it's a good idea embed the aluminum inside of the sandwich, and after that the transom will be completely rigid. Yes, I love it. Install in the moment of that you fabricate the new transom. I recommend install those reinforced triangles inside of the boat in order to support better the new transom. This is great because right now the transom is properly supported. Yeah, the transom is critical. It's a critical part, especially if in the transom you have the outboard or you have the steam drive connected over there. That transom should be strong. And now we are going to talk about the keel. The keel, that the center of the boat. And depending of the angle of the V configuration, depending of this angle, this is an important angle, especially in electronics. In the course of electronics, we are going to install transducers, and the transducers are coming in different angles depending of this angle. Yes, those transducers are coming originally in different angles depending of this, in order to send the reading directly to the ground. And this is especially in fish finders, this is important, the location of the transducer. And in the course of electronics, we are going to learn about that procedure. This angle is critical. It's critical, and I am going to explain the procedure to calculate that angle. With the, you remember your concept of trigonometry, sine, cosine, tangent? Yes, we are going to use those concepts in order to calculate that angle. Okay, my friend, in the structures there are both with an open fly bridge like this, or a closed fly bridge like the second one. The second picture is closed fly bridge. Yes, depend of the design. Those fly bridge is another console, because you have another pilot helm located over there. And yes, we are going to learn the procedure to install the additional helm, the power steering unit, the helm over there, and the wiring in order to start and stop the engines over there. This is part of our course of auxiliary in rigging. We are going to learn about that, and in electricity, of course, this is other of our best sellers, the electrical classes. We are going to learn about that procedure. Okay, this is the fly bridge. There are fly bridge enclosed by plastic like this. During the summer, the temperature inside of that fly bridge is too hot. In the course of air condition, we are going to learn the procedure to calculate the capacity of the air conditioning equipment according with the material of the room. If the material is fiberglass, if it's closed with no windows, it is enclosed with plastic, with vinyl like this. Depending on the material, you need air conditioning equipments with more or less capacity. We are going to learn the procedure to calculate those equipments. Okay, my friend, and right now we are going to start to calculate important factors. The speed of the boat, the hull speed, the horsepower, the capacity of the boat, how many people, the horsepower required to move the boat at this hull speed, the efficiency, the fuel efficiency, and comparison in between gasoline and diesel, and the fuel consumption in gallons per hour. This is a great section, and I hope you enjoy this section. Okay, my friends, now we are going to start with the calculation of the hull speed. Normally, this is that speed that we are going to calculate. This is the speed recommended by the manufacturer. The speed recommended by the manufacturer in order to avoid critical consequence. In order to avoid that the hull be affected, crack for vibration, or yes, this is the speed recommended for the manufacturer according with the length of the boat and the weight of the boat. As a very general rule, the maximum speed of any power boat with a displacement hull, commonly called, is the hull speed, and this is basically governed by a simple formula. The hull speed of a boat is equal to 1.34 times the square root of the water line. 1.34 times the square root of the water line. This is for an inboard boat, no outboards. For outboards, the formula is a little different. It's 1.7 times the square root of the water line. This formula is for inboard. This is for inboard engine, and this is for a displacement hull. Okay, the water line is approximated 80% of the total length of the boat. is in between 80-85%. The majority of the engineers use 80%. And one important conversion that we are going to use is that 1 miles per hour is equivalent to 0.87 knots. Important factor. Okay, displacement Hall is limited according with the horsepower. For that reason, the formula that we are going to use is that the Hall speed is equal to 1.34 times the square root of the water line. For a small boat, we are going to use, instead of 1.3, we are going to use 1.7. That's I explained before about that. Once again, the Hall speed is equal to 1.34 times the square root of the water line. Suppose that the total length, the length of the boat, is 45 feet. The Hall speed is equal to 1.34 times the square root of 45 times 0.80. This is 80% of the total length, and this is the Hall speed, right? This is very important. This is the Hall speed in knots. In this particular case, the Hall speed will be 8.28 knots. And remember, 1 mile per hour is equal to 0.87 knots. Okay, if I have 8.28 knots, how much miles per hour are? The speed in miles per hour is equal to 8.28 divided by 0.87, and the speed in miles per hour is 9.52 miles per hour. Alright, this is a great example about to calculate the speed of the boat, the Hall speed, in miles per hour, according with the length of the boat, using the formula for inboard boats is 1.34 times the square root of the water line. Normally the water line is in between 80 and 85% of the total length. Normally I use 85%. Okay, my friends, and now the question is how much horsepower you need in order to reach that Hall speed. There are several factors to take in consideration when you try to calculate the horsepower required in your boat. One of the factors in consideration is the total weight, important. The fuel efficiency, the type of hull, the propulsion system, the use of the boat, depend where will be used the boat, and the number of people on the boat. Those are important factors in order to calculate the horsepower required. Okay, we are going to start to calculate the capacity of the boat. If your boat doesn't have a plate with the capacity of the boat, the people, you can calculate that capacity easily. The number of people is equal to the length of the boat in feet times the width of the boat in feet and divided by 15. Yeah, simple formula. Normally in the boats you found the plate with the capacity of the boat according with the weight of the boat and the capacity of the motor in horsepower. Okay, my friends, and now we are going to try to calculate the horsepower that you require in the engines according with the length of the boat. This is an important formula. This is the rule. In general, the rule of thumb is based on the weight, and they say that you have in between 40 and 25 pounds of weight per each horsepower. Once again, you have in between 40 and 25 pounds of weight per each horsepower. For that reason, normally I divide it by 30. One important thing is, in order to calculate the horsepower required, is use the total weight of the boat. In other words, use the weight of the boat fully loaded with gasoline, with water, with batteries, with people. This is the maximum weight of the boat. In order to calculate the total horsepower, we are going to use the total weight with the boat fully loaded in pounds, and we are going to divide it. By 25 or 30, in between 25 and 30. This is the recommendation. Don't forget, the total weight fully loaded and divided by 30. This is the rule in order to calculate the total horsepower required. Yeah, this is the total horsepower required with the boat fully loaded. All right. Suppose that I have a boat fully loaded of 25 tons. 25 tons is 50,000 pounds. Is approximated 50,000 pounds. 50,000 pounds. All right, and we are going to divide it by 30. It's 50,000 divided by 30, and this is 66.66 horsepower. You need approximated 1700 horsepower. What is the meaning of that? You need in total 1700 horsepower. If you divide it by 2, probably you need 2 engines of 800 horsepower each engine. Yeah, this is the example. All right, this is the capacity in horsepower, the total capacity. If you want to use 2 engines, you need approximated 850 horsepower per engine. And normally I added 20% for safety factor. I added 20% for safety factor. In other words, I need 150 times 1.2 I need around 1000 horsepower in each engine. This is the requirement. This is the capacity in this particular example. The numbers are big numbers, but this is the situation. You use the total weight and you divide it by 30, and this is the horsepower, the total horsepower required in order to keep the boat running at that whole speed. And now if you want to install 2 engines, you divided that capacity in 2, and for safety factor you added 20%. This is the procedure to calculate the horsepower required for the boat in order to keep the boat running at the whole speed recommended by the manufacturer. Yeah, don't forget, the rule of thumbs is divided the total weight in between 40 and 25. Normally I recommend divided by 30. This is the recommendation. Okay, my friends. Other important recommendations, that formula that we are going to use in our course in the future. Don't forget that you can convert mechanical horsepower into electrical horsepower with this simple formula. 1 horsepower is equivalent to 746 watts. This is electrical power and this is mechanical power. 1 horsepower is equivalent to 746 watts. Yeah, and additionally, only to convert horsepower into torque, 1 horsepower is equivalent to 550 foot-pounds per second. Yeah, this is a good reference in order to convert horsepower into torque. And the magic formula to convert torque in foot-pounds into horsepower or vice versa is the torque is equal to 5252 times the engine horsepower divided by the RPMs of the engine. Okay, remember that we are going to calculate the torque at different range of RPM. We are going to calculate the torque in idle. We are going to calculate the torque at the operational RPMs recommended by the manufacturer, and we are going to calculate the torque at wide open throttle or full RPMs. Of course, because the wide open throttle is higher than the operational RPM and higher than the idle, the torque in wide open throttle is less than the torque in idle. The maximum torque normally is in idle. Yes, my friend, remember that the curve of the torque is like this. Remember, torque is equal to 52 times the engine horsepower and divided by the engine RPMs. And normally, if you do the graphic in between the torque and the engine RPMs, the graphic is like this. This is idle. This is the operational. This is the maximum efficient RPMs. This is wide open throttle. Yeah, normally the torque is maximum in idle. This is the torque at operational RPMs, and this is the torque in wide open throttle. And this is in idle. Yeah, the torque in idle is the maximum, but normally this is the operational RPMs recommended by the manufacturer because the horsepower, the curve of the horsepower is like this, and this is the point of maximum efficiency. This is the point where the engine is running at the maximum efficiency, and this is the point where the engines produce the maximum torque with maximum fuel efficiency. This is the point of maximum efficiency. Right now we are going to talk about that. Normally the horsepower that we use in this point is the brake horsepower, because this horsepower that you have over there, this is the horsepower that you calculate with the previous formula. But the brake horsepower is the real horsepower. Remember, when you buy a motor or when you buy a boat in the catalog, the manufacturer says that the horsepower, for example, is 600 horsepower. Okay, this is the ideal horsepower at sea level in ideal conditions. But normally in operational conditions, the horsepower is a little less because you have a loss of power for temperature, for altitude, for humidity, for different external factors. And normally the brake horsepower, this is this slide, the brake horsepower is around 96% of the original horsepower. Yeah, it's because you have a loss of power for temperature, loss of power for external conditions like altitude, like humidity, like the engine is old, the amount of miles on the engine is superior, and you have a lot of loss of power. For that reason, the brake horsepower, BHP, is approximated 96% of the original horsepower. Another important factor that we are going to take in consideration is the torque. Remember, we know the formula. Torque is equal to 52 times the horsepower divided by the engine RPMs. We are going to use the torque in the future because with the torque we are going to calculate the thrust. How much thrust produce the engine? The thrust depends on other different factors like the weight, the length of the boat, the pitch of the propeller, the type of propulsion systems, if it's a steam drive system, if it's in power, if it's V-drive, depending on the propulsion system, the weight, the horsepower, and the type of hull, we are going to calculate the thrust. Yes, but the element that is important for us is the torque, more than the horsepower. The torque is directly related with the thrust. The torque is directly related with the thrust, okay? For that reason, all the time we are going to refer our concepts, our calculations to the torque, not to the horsepower. Okay, my friends, and don't forget the magic formula, 5252 divided by the engine RPMs. Okay, the fuel efficiency. This is another important factor because the majority of the manufacture of engines, boats, cars, they consider that the boat, the car is efficient basically in terms of the fuel efficiency. But in order to define efficiency, I am going to explain something in order to calculate efficiency, because in the future, in our course, we are going to calculate efficiency in different ways. We are going to calculate fuel efficiency, we are going to calculate the thermal efficiency, we are going to calculate volumetric efficiency, we are going to torque temperature efficiency, we are going to calculate the efficiency in different ways, according with different factors of reference. But in general terms, the efficiency is calculated with respect to different factors. For example, suppose that you say in your home, to your wife, I am going to bring at the end of each month, I am going to put over the table $1,000. Okay, your wife said, okay, that's okay, $1,000 at the end of the month. Okay, but the first month you bring $800. And you say, sorry, mommy, I only bring $800 because. Okay, what is your efficiency? Your promise was $1,000 and you bring $800. Your efficiency is 80%. Efficiency is the actual situation, the actual value divided by the theoretical value times 100. Oh, the actual that you have on the table is 800. The theoretical 1000 is times 100. Your efficiency is 80%. Simple. This is the formula to calculate efficiency. It's the actual situation divided by the theoretical situation times 100. Alright? I want to calculate the thermal efficiency of this engine. Okay, let me check in the manual. The temperature, the ideal temperature, operational temperature of this engine is 180 degrees. My engine is working in this moment at that temperature. I divided the actual by the theoretical times 100, and this is the thermal efficiency. And you can calculate the fuel efficiency. What is the theoretical fuel efficiency of this car? Is 32 miles per gallon. Efficiency, fuel efficiency. Okay, the theoretical, according with the manual, is 32 miles per hour. And you do the measurement, you put fuel on the tank, and you check with the odometer, and you verify that the real situation, excuse me, this is the theoretical. The theoretical is 32. And you verify that in the reality, the consumption is 28. Is 28 divided by 32 and times 100 is 87.5%. The fuel efficiency of your car is 87%. It's not 100%. According with the manual, the manufacturer said that it's 32 miles per gallon. And in real life is 28. The efficiency is 87%. You can calculate the efficiency in different ways with respect to different factors. You can calculate the efficiency with respect to the temperature, to the torque, to the fuel consumption. Yeah. Don't forget, it's the actual divided by the theoretical times 100. Very important. Okay, we are going to talk later about the gas and diesel engines. We are going to spend like 6 months talking about those engines in details. We are going to disassemble those engines in pieces completely. We are going to rebuild the engine step by step. A couple of bestsellers, the diesel and the gas classes. Wonderful classes. I hope you enjoy those classes. And we are going to verify why the diesel engines are more efficient than gasoline, and why the diesel engine have a bad reputation on the world. But I have a couple of chapters where I explain that this is not true. It's not because the engine, it's not because the diesel engine, it's because the quality of the fuel. Please check in my book. Check in my book those chapters. This one and this one. Wonderful chapters. In those chapters, I open your eye. Oh, wonderful. The diesel engine is highly efficient. The problem is not on the engine. It's in the quality of the fuel in your country. That's the problem. The fuel, the diesel in your country is not good. It's a diesel of bad quality. Yes, for that reason in your country, the majority of the diesel trucks, the diesel cars, black smoke a lot. It's not because the diesel engines are bad. It's because the quality of the fuel. Check those chapters in my diesel book. Check those episodes in my webpage. Okay, my friends, we are going to try to calculate the consumption of fuel. But I need that you keep in mind this explanation. If you have well-maintained 4-stroke gasoline engines, that engines burn 0.5 pounds of fuel per each horsepower produced per hour. That gasoline engine burns 0.5 pounds of fuel per each horsepower produced for that engine in 1 hour. That's okay? The gasoline engine. The diesel engine burns 0.4 pounds of fuel per each horsepower produced in 1 hour. The diesel engine burns 0.4 pounds of fuel per each horsepower produced in 1 hour. And the gasoline 0.5 pounds. Which engine burns more fuel for the same power? Gasoline. Finito. End of the discussion. This is one of the examples. I have hundreds of examples. This is one. Yes, the gasoline engine burns more fuel per each horsepower produced per hour in comparison with the diesel engine. I'm going to explain later why. Alright, don't forget that number, 0.5 pounds and for gasoline and 0.4 pounds for diesel. We are going to check the weight. This is the situation. Gallons per hour calculation. The boat magazine has provided some calculation that you can use in order to understand those numbers. The weight of the gasoline is approximated 6.1 pounds per gallon, and the diesel is 7.2 pounds per gallon. Yes, the diesel is heavy in comparison with the gas, the liquid, the fuel. Yeah? the weight of the diesel is 7.2 pounds per gallon and 6.1 pounds per gallon of the gasoline. It's practically 1 pound more the diesel in comparison with the gasoline. Okay, and now we are going to calculate the equation, the gallons per hour. And in order to calculate the consumption, gallons per hour, we are going to use this formula. Is the specific fuel consumption times the horsepower of the engine divided by the specific weight of the fuel. That's too simple. For example, we are going to do an example with an engine 300 horsepower gasoline. The engine 300 horsepower gasoline have this situation. Okay, the horsepower of the engine is 300, is gasoline. We are going to calculate the consumption in gallons per hour, and it's simple because the horsepower is 300, and we are going to multiply times 0.5 because this is the consumption of the gasoline engines in order to produce 1 horsepower in 1 hour. And we are going to divide it by the weight of the gasoline. The weight of the gasoline is 6.1. And in that case, according with that formula, is 24.5 gallons per hour. This is the consumption of that engine. Yeah, simple. Don't forget, all the time we are going to use this formula. The consumption in gallons per hour is equal. The consumption in gallons per hour is equal to the specific fuel consumption. Times the horsepower and divided by the weight of the fuel. The gallons per hour in gasoline is 0.5 times the horsepower divided by the weight 6.1 for gasoline, and for diesel is 0.4 times the horsepower of the engine divided by 7.2. That's for diesel. And with that formula you calculate the consumption in gallons per hour. And don't forget the formula for the efficiency, the actual situation divided by the theoretical times 100. And those are the magic formulas that we are going to use in the future to calculate the whole speed, to calculate the horsepower required for the engine, and to calculate the fuel consumption and the efficiency. I hope you enjoy this video.